Alright, hello everyone. So let's solve more integration by parts problem, but not obvious ones, okay? Alright, so we have to integrate natural log x. Now, if you have watched my basic integration review series, I told you there that integral of natural log x, most of you think it as 1 over x, but it is not 1 over x. Derivative of natural log x is 1 over x, but not the integral. So really, how do you integrate natural log x? Well, it's not obvious. It's not a basic integral, okay? Surprisingly, we have to use integration by parts here. So, let me show that to you. Now, you would be thinking, well, don't we use integration by parts when we have to integrate a product of functions? Like, f times g. Here, we only have a one function in the integral, right? Then how come we use integration by parts? So, let me show this to you. Actually, there are two functions here, so I will show that to you. But first, let's choose u. Okay, so we are going with the LIAT rule, and we have logarithmic function. But what is the other function? Well, we have a constant here, which is 1. So we can say this as 1 times natural log x, right? It's just we don't write 1. Okay, so you can think 1 as x to the 0. So you can imagine that actually there is another function which is x to the 0. It's a constant. So, but anyway, logarithmic functions get priority because it is on the top of the list. So definitely u is natural log x. Now what is dv then? Now here's the trick. dv is everything else except u. So u is natural log x, everything else is 1 dx, just a dx, right? Okay, I want you to wrap your head around this very carefully. Now then we have to find du. So if you differentiate u, then we get 1 over x, because derivative of natural log x is 1 over x. So du is then 1 over x dx. So let's write it down. Now one more thing we needed, we need v. If you integrate, what is v? What do you think? If you integrate 1, because what you have here is 1 dx, right? So if you integrate 1, you get x. So v is x. Alright, so let's use the formula. uv minus integral of v du. Okay, so uv, so where do I write this? Okay, let me write it here. So u is, what is u? Natural log x. And what is v? V is x, let's write it here, minus in v is x, du is actually 1 over x dx. Okay, alright, so now if you look at the integral on the right hand side, we can simplify this x, right? Okay, so if you simplify, what we get is x natural log x minus here 1 dx. Now if you integrate 1, you get, of course, x and plus arbitrary constancy. So this is the answer. This is what you get if you integrate natural log x. See, it's not a basic integral. You have to use integration by parts. Remember it, okay? More importantly, understand the strategy. Now I'm going to change this problem a little bit. I'm going to teach you another thing. This is going to be a little bit tricky. Let's integrate natural log square root x, okay? Now why is this important? Similar type of problem, similar strategy. U is definitely natural log square root x, right? And dv is same as the previous problem dx, right? Because the same thought process. We have a one function, and that is natural log square root x, and it's a logarithmic function. It gets the priority, right? It is u. Now don't get carried away with the square root x. It's just inside natural log x, nothing to do with the choosing u. Now here's the thing. Now you could ask, well, can't we use integration by substitution here? Because we have an inside function. Inside natural log x, we have square root x. We can choose u to be square root x. But here's the question. Why can't we use integration by substitution here? Because not only you need an inside function, you need its derivative to be somewhere else in the integral. Derivative of square root x is not somewhere else in the integral. So don't use integration by substitution here. Alright, so let's move on. Now the tricky thing here is to find the derivative of u. Now derivative of natural log x is 1 over x. So derivative of natural log square root x is 1 over square root x. Okay. But here we have to use chain rule when we differentiate, right? So be careful with that. Okay, now we want to differentiate square root x and multiply it by this. Now square root x is x to the half, so if you differentiate x to the half, it's half x to the half minus 1 negative half. Okay, I did that fast, but pause and think about it. So this is the derivative of natural log square root x. Now what I'm gonna do is let's see what we can do. So we have x to the half here, that is the square root, and we have 1 over 2, and let's bring this term right here to denominator, so it becomes 1 over x to the half. Sign switch to positive, right? X to the half, it's x, right? It's like 1 over square root x times 1 over square root x is 1 over x, and with this 2 it's 1 over 2x. So this is du over dx. I want you to understand that very well. Try to do it by yourself, okay? Try to convince yourself. Now from here, du is 1 over 2x dx. So that is tricky. Now let's see what else we need. Well, we need v. So dv is dx, so v is x, right? If you integrate 1, you get x. Okay, so let's use the formula. Now from here on, it should be easy. Let me do it here. uv minus integral v du. What is u? Natural log square root x. What is v? It's x minus, oops, I need space, v is x. du is 1 over 2x dx. Okay, so x cancel out here. So here we get x natural log square root x minus here 1 dx, right? So if you integrate that 1, you get x plus c. So this is what you get if you integrate natural log square root x. Okay, all right, so let's solve another problem, another type of a problem. Well, let me do another similar type of a problem and then move on to a different one. Sin x natural log x, natural log cosine x. This is also a little bit tricky, same thought process. Now here, well, we have two functions here. So what is u? We have a logarithmic function, trigonometric function. Well, we can choose our u to be logarithmic function, natural log cosine x, and we can choose our dv to be everything else, sin x dx. Logarithmic function gets the priority, right? So du over dx, derivative of u is 1 over cosine x. That's by differentiating natural log. Now by chain rule, derivative of cosine x is negative x. Again, we have to use chain rule here. So if you here, the v will be, if you integrate sin x, you get negative cosine x. Okay, be careful with that. So here du is, if you take dx to the other side, du is sin x cosine x dx. Okay, all right, so we have all the tools that we need, right? Okay, so the formula, uv minus integral of v du. So u is natural log cosine x, and we got v to be negative cosine x. So let's write it here, negative cosine x, minus v is negative cosine x, du is negative sin x over cosine x dx. Now cosine x cancel out. Okay, now here let's deal with this negatives carefully. Negative times negative positive, and with this negative it's negative again. So negative cosine x, natural log cosine x, here negative, you have to integrate sin x. So if you integrate sin x, you again get negative cosine x. With that new negative and this negative, it becomes positive. So cosine x, natural log cosine x plus cosine x plus c. So oops. So this is the solution for that integral. Again, I think the tricky part here is that this applying this chain rule. I wanted to show it to you. All right, so let me do another type of a problem, which is, it shouldn't be hard, but it is a little bit different. Natural log x over x to the 4 dx. Now we have two functions. Yes, we have 1 over x to the 4, which is an algebraic function, and we have a logarithmic function, natural log x. So what is u? Well, u is logarithmic function, and dv then is dx over x to the 4, everything else, right? So don't forget that it's a fraction. Now you can make your life easy if you just write that fraction as dv x to the negative 4. Okay, so you could have written this integral at first place as x to the negative 4 natural log x. It's just easy for us to, it's just more comfortable than having a fraction, right? Now let's carry on. So du over dx is derivative of natural log x is 1 over x, and du is 1 over x dx. Okay, now if you integrate x to the 4 to get v, we get x to the negative 4 plus 1 is negative 3 divided by negative 3. Do that integration carefully. So we have all the tools that we need. Okay, so let's use the formula. So the formula is uv minus integral of v du. What is u? Natural log x. What is v? X to the negative 3 divided by negative 3, and v is x to the negative 3 divided by negative 3. Du is 1 over x dx. Okay, so here, well, this one nothing happens, x to the negative 3 over negative 3 natural log x. But here we can simplify. Well, be careful. Here this x can be taken into numerator and written as x to the negative 1. So x to the negative 3 times x to the negative 1 is x to the negative 4, right? Be careful with that. When you add negative 3 and negative 1, it becomes negative 4. Now this negative and this negative here, it becomes positive here over 3 dx. Now if you integrate that x to the negative 4, you get x to the negative 4 plus 1 is negative 3, and you divide by another negative 3, and with this 3, okay, there's another 3 on the bottom originally, okay, here. Now plus c, so what we get is x to the negative 3 natural log x over negative 3. Here this negative here, 3 times 3 9, it's multiplication between them, not addition. Okay, so this is the solution. All right, I think there's another one problem in my exercise, but I will give you the idea how to solve it. Now when you see it, you will know. X over e to the x. How can you integrate this? Well, we just learned the trick. Write that e to the x in the numerator as e to the negative x. Then use integration by parts. It will make your life easy. Well, you have to do it at some point, at least in the middle of the problem. Okay, all right, so I will let you do that problem. In the upcoming videos, we are going to solve much more trickier problems in integration by parts. So hope you guys stick around. All right, thank you. Bye bye.